is all about graphing a function rule. So we've been coming up with all these function rules, right? Y equals 2x plus 7, y equals x minus 9, y equals 3 to the x power, all these different function rules, okay? Today we're gonna do a lot with how you come up with the graph of them, okay? So typically on these types of problems, you're gonna pick the numbers -2, -1, 0, 1, and 2. It won't always work out that way because sometimes it's more of a real world type problem where we're talking about things that it doesn't make sense to use negative numbers for. But if it's just a general equation like this one right here, you're just gonna plug in -2, -1, 0, 1, 2, okay? So here's what I'm gonna show you. This first setup, I didn't give you a t-chart. You know what a t-chart is? T-chart is this one, right? X and Y, and you're just filling in numbers, okay? From here on out, you are welcome to use a t-chart. This is just me showing you how you come up with the numbers for a t-chart, okay? So if you want to use a t-chart on every single problem, you may use a t-chart on every single problem, but I want you to see this for this one. So what happens is if I'm plugging in -2 for x, this is my x here, right? I would do -2 times, and then whatever my x value is right there, plus 1. Well, on this first one, we're plugging in a -2. So it's -2 times -2 plus 1. So all the way through, this is -2 times something plus 1. -2 times something plus 1. -2 times something plus 1, and -2 times something plus 1. Okay, you're using the function -2x plus 1, and you're just taking out the x value, and you're putting in the number that we want to take its place, okay? So on this second one, it's going to be -2 times what? -1. On the third one, it's going to be -2 times 0, and then -2 times 1, and then -2 times 2, okay? And that's going to give us a new point. The point is going to be an x and y value that we're going to put on our graph. Okay, so this is really the x and the y that normally show up on your t-chart. The x value is there for you. It's -2, -1, 0, 1, and 2. The y value is whatever this middle section works out to. So what you're going to do is you're going to calculate this setup. -2 times -2 is +4 plus 1, okay? And you may use your calculator for this part. Just plug it in. -2 times -2 plus 1. You should get 5, okay? -2 times -1 is a +2 plus 1 is 3. -2 times 0 is 0 plus 1 is 1. -2 times 1 is -2 plus 1 is -1. And then -2 times -2 is -4 plus 1, which is -3. Okay? Now your job is to graph this. And a lot of people struggle with where to move when you graph. So that's where I'm going to start right now. When you are graphing, I'm going to use Izzy's little trick here. Your numbers in this quadrant are both positive. Your x is positive, your y is positive, right? This is your x, this is your y. What happens in the second quadrant? The first one is what? Like moving to the left makes it positive or negative? Negative, and then moving up makes it positive, okay? Third quadrant is going to be negative, negative. Fourth quadrant is going to be positive, negative, okay? So let's look at our numbers. -2, 5. You move where? 2 to the left or right? To the left. So you're going 2 to the left, 5 up. 1, 2, 3, 4, 5. That's -2, 5. Okay? And if you think you're 100% confident on graphing, I don't care. I want you to look at this and make sure that's where you put your -2, 5, because I see a lot of mistakes made just on plotting points. Okay? Yeah, Brooklyn.
Negative looks like
It does. He looks like a sad face, huh? Or maybe this guy's just winking.
Yeah, I was thinking that, and then the other one.
Yeah. Okay, anyway. -1, 3. You're going 1 to the left, and then 1, 2, 3 up would put you at that point right there. Okay, so this is your -1, 3. This is your -2, 5. So 0, 1, how far do we move left and right? You don't. It's a 0, right? And then we move 1 up. Okay? 1, -1 is going to go here. And then 2, -3 is going to go here. And then I would prefer you use a straight edge here so that you have a nice, pretty graph. That can be the edge of a book. It can be the edge of a piece of paper, or you can use a straight edge if you have a straight edge. A ruler, whatever. Yes. If you want to borrow one of mine while you're in my classroom, you totally can. You just can't take it home with you. Okay, so that's the first setup. Any questions on that?
No.
Okay. These two things are very important. Number one, when your data is all positive. So like this one, we had some negatives, right? But when everything's positive, no negative numbers, you don't need any other quadrant but quadrant 1. Okay, so just give it that first quadrant if that's your setup. And then you have to count by a consistent number on each axis when you're graphing. So if I'm counting by 1s on the bottom, I need to count by 1s on the bottom the whole way. That doesn't mean I have to count by 1s vertically. Okay, you can count by something different vertically than you count by horizontally, but you have to count on the one axis by the same thing the whole way. So if I'm going to count by 10s here, I can't go 30, 40, 50, 60, 70, 80, right? If I do that, what do I got to put in? The little zigzag. Remember the zigzag I showed you? If you're going to skip a big chunk, put a zigzag in, okay? Okay, let's look at example 2 here. This one says you have the equation W equals 146C plus 30,000, okay? W is the total weight in pounds of a truck that carries C cubic feet of concrete. So C is representing concrete. W is representing weight in pounds, okay? It says if the capacity of the truck is 200 cubic feet, what is a reasonable graph? Now, think about this. The capacity of the truck, that's your C. How many cubic feet a truck can hold is 200 feet. Is that saying that's the least amount it can hold or the most it can hold?
The most.
That's the most. So your X value, which is your C value right now, right? This number can't be any higher than 200. That means we're looking for what are some reasonable numbers to put as our X values or our C values here, okay? I always say it's good to start with 0, just to give you a simple one to work with, because that's usually a good starting point with things like this. But we want to get up to 200 because that's max capacity. So you're looking for what is a good set of numbers to use. If you can count by a set amount, it's beautiful. Do you see a number you could count by here? 50, right? If we go 0, 50, 100, 150, okay? That would give us a good setup. Now, again, I don't need you to do this part. If you want to write that in, great. If you want to just plug it into your calculator, I'm fine with that. I'm going to write here what you would plug into your calculator just so everyone knows what's going on. But you don't have to do this part for me, okay? So here's what you would do. You would do 146 times what? Times 0 for this first one, okay? So 146 times 0 plus 30,000. Then you would do 146 times 50 plus 30,000. Then you would do 146 times 100 plus 30,000. Then you would do 146 times 150 plus 30,000. And then 146 times 200 plus 30,000. So when you plug all those in, like I said, use your calculator. There is no reason you should try to do this by hand. Plug it into your calculator. If you plug this in, if I plug a 0 in, what do I get? 30,000, right? 0, 30,000. If I plug 50 in, I get 50, 37,300. Okay, if I plug 100 in, I get 44,600. If I plug 150 in, I get 51,900. And if I plug 200 in, that's our max capacity, so we can't go any higher than that, I get 59,200. Because it's good to be challenged.
I don't have room. No.
Okay, so we're gonna graph this. Okay, so all you really need is that strip, because that's all your numbers. What are the two things we're talking about? What are our variables?
C and W.
C and W. It's concrete, right? Which is really our X, so that's gonna go down here. So this is concrete. Technically, we're talking about cubic feet of concrete. I don't care if you don't put the cubic feet in, that's fine. And then what's the other one? The total weight in pounds. Okay, so this would be our weight in pounds. All right, now we got to figure out what makes sense. Our X's are counting by 50s. You can count them by 50s if you want, or if you want to space it out a little more so it's not all on top of each other, count by 25. So this would be 25, 50, 75, 100, 125, 150, 175, and 200. It just gives you a little more room to work with if you count by 25s, okay? Okay, now our weight. And this one requires a little bit of thinking through what we want to count by. So what's the lowest weight? 30,000. The highest? 59,200. Okay, so you have options. Again, you could do a little zigzag and you can start at 30,000 if you want, or you can just count by some set number. But we have to get up to 60,000 essentially. Okay, I would probably just count by 10,000s because that would get us up 6 spaces to 60,000. If you want to do something different, you totally can. You just got to make sure it's going to fit on the graph. Okay, but I'm going to do 10,000. So this would be 10,000, 20,000. 30,000, 40,000, 50,000, and 60,000. And you don't have to go any higher than that because your numbers don't go any higher, so you can just stop there. All right, so now we got to plot them. Our first one is 0, 30,000. So I'm not moving left and right at all. I'm going up to 30,000 and I'm putting a point right there. Okay. Now think about where your next one's going to be because it's not going to fall perfectly on one of the crossbars, right? So it's 50, 37, 3. So you got to go over to 50, right? We're moving over to here. Up to 37,300. Is that going to be closer to the 40 or the 30?
40.
The 40. So you're going to go probably here-ish. Okay. Then you go to 100, which is almost 45, so almost perfectly in the middle between 40 and 50. Okay. Then 150 is just above the 51,000. Sorry, just above the 50,000 is what I meant to say. And then 200 is almost to 60,000. Okay. Okay, now here's my question for you. For this graph, could your amount of concrete be somewhere between 0 and 50 pounds cubic feet, sorry. Cubic feet, yes. So this is actually gonna have a line drawn through it because it could be anywhere on this line that works. The one thing you need to be careful of is what's the max for the truck? 200. So your line can't go past 200 because the truck can't hold it. Okay? So your line is going to look something like, this is why I say use a straight edge, something like that. Okay? Don't make your line keep going because you can't. The truck won't hold it. Questions on that? Okay. So let me talk to you about the solid versus the dotted. Are you talking to me? No, hey, I'm doing a lesson over here. So there's two different kinds of graphs, okay? There's a continuous graph and there's a discrete graph. A continuous graph is unbroken, like the one we just did was continuous, it keeps going. It will look something like this, right? Where it's just a line that's connected. Whereas a discrete graph is distinct, isolated points. Like this point works, and this point works, and this point works, but other ones don't. So a discrete graph is just dots. You don't draw the line in. Okay? So pay attention. Sometimes they're going to say, is this discrete or is it continuous? And you need to think about what makes sense there. So let's look at an example and see if we can figure out what makes sense here. So example 3, this is talking about two different things. It says the amount of milk used to make cheese and the price of cheese is, the price the cheese is sold at are these pieces of information. 1 gallon of milk makes 16 ounces of cheddar cheese, and each wheel of cheese costs $9, okay? Write a function for each and graph them. Are the graphs continuous or discrete? So here's what we're going to do, okay? If we're going to write an equation for this first one, we're going to use M as our gallons of milk and W as our ounces of cheese. It says 1 gallon of milk makes 16 ounces of cheese. So can you figure out what that would look like? If 1 gallon makes 16 ounces, then 2 gallons would make 32 ounces, right? If you want to set it up as a T-chart, maybe that would help you to see it a little better. This is milk and weight in ounces. So 1 gallon of milk makes 16 ounces. So 2 gallons would make 32 ounces, or 3 gallons would make 48 ounces, okay? You're looking for what is that relationship? What am I doing to 1 to get 16? You're multiplying the M by 16, right? So you would say your equation is W equals 16 times M. Okay? Now here's the question. If we're talking, we already said gallons of milk. That's going to go down here. And then ounces of cheese is going to go over here. Can you get 40 ounces of cheese? Yeah, you would just use a fraction of a gallon, right? 2.5 gallons might make, I don't even know what that would be. Perfectly in between. 40. It would make 40. 2.5 gallons would make 40 ounces of cheese. So is that going to be continuous or discrete? Continuous, right? Because I can use any amount of milk. I can pour 2 ounces in. I can pour 4 ounces, 5, 6, 7. I can pour any amount of milk in and get some amount of cheese, right? So this one's going to be continuous. The way we would set this up, let's do gallons. We're going to count by ones. 1, 2, 3, 4. Okay. For ounces of cheese, you could actually count by 16 if you wanted to. If you want it to fall perfectly, you totally could. I'm just going to count by tens for ounces of cheese here. So 10 ounces, 20 ounces, 30 ounces, 40 ounces, 50 ounces. Okay, if we're going to plot those, we're plotting those numbers. So 116 would be about in the middle. go quickly then. 2 ounces would be 32. Okay, 3 ounces would be 48. But we said because you can have ounces in between there, you draw the line in. Oops, I missed my line. So this would be a continuous graph. Okay. Okay, now think about this other one. It says each wheel of cheese costs $9. Have you seen wheels of cheese in the grocery store before?
Yeah.
It literally looks like a wheel. It's like round like this, okay? When you go to the grocery store, are you allowed to like cut a piece off and take just a portion of that wheel of cheese?
Yeah. Yeah. At the carniceria.
Yeah?
Yeah, they're like, it's like the stinky cheese and it has it, and it's like if you just want that part, they give you that part.
Oh, really?
And they weigh it, how much like.
Oh, if you're buying it by the pound, yes. Okay, I'm saying the ones that are like prepackaged,
Oh, like
wrapped.
at Ralph's.
They're wrapped, yeah, like at Ralph's. They're
Oh,
wrapped
okay.
up a wheel of cheese. You cannot go to the counter and say, I didn't want all that cheese, so I cut this one in half. They would be like, nope, sorry, you're paying for the whole thing, okay? What kind of graph do you think that makes?
It makes the discrete.
That's discrete, because you can buy a wheel, or 2 wheels, or 3 wheels. You can't buy 1.5 wheels of cheese, okay? So this one's gonna be continuous, and it said, or sorry, discrete. It says it costs $9. So your equation, your amount of money for the number of wheels, it is $9 per number of wheels will be how much money it costs, right? 9 times the number of wheels. So when you graph that, if you want the T-chart to see your numbers, nope, that's your A, your N. So this would be N, this would be A. And we would do, for 1 wheel of cheese, it's $9. For 2 wheels of cheese, it's $18. For 3 wheels of cheese, it's $27. Okay? So when you graph that, oh, I wanted to do more than this. We're going to leave that. We'll come back to that tomorrow. Let me do this one, because this is more important right now for you to make sure that you get this. If we're going to graph this, what are the 5 numbers I told you to plug in? 0, 1, 2, and we want negatives, right? So we're going to go -2, -1, 0, 1, and 2. Okay? If I plug that in here, I'll just take it. Thank you. If I plug that in, I'm saying y equals the absolute value of -2 minus 4. What's the absolute value of -2? 2, right? So 2 minus 4 is -2, okay? Then I'd go absolute value of -1 minus 4 is -3. Absolute value of 0 minus 4 is -4. Absolute value of 1 minus 4 is -3. And absolute value of 2 minus 4 is -2. Okay? Look at what happens when I graph that. -2, -2, -1, -3, 0, -4, 1, -3, 2, -2. My graph is a V shape. Okay? Every single time that you have absolute value, you will get a V shape. Okay? So like I said before, make sure these are the numbers that you're plugging in if it's just an equation like this. If it's a real world problem where we're talking about milk and cheese and all of that, you need to ask yourself what makes sense. But if it's not, plug in -2, -1, 0, 1, and 2. Okay? We'll come back to the rest of it tomorrow because tomorrow is just a day to review this. So we'll come back.